Download this code from codegive.com, link in the description below. Bearer Token API Key Authentication, Part 7, Advanced Topics and Best Practices. This tutorial delves into advanced topics and best practices for implementing and managing bearer token API key authentication, building upon the foundation established in previous parts. We'll explore areas like token rotation, revocation, multi-factor authentication, MFA, integration, token store optimization, monitoring, and security auditing. This installment will be a bit more theoretical and discussion-based, with code examples serving as illustrations of potential approaches rather than a single, prescriptive implementation. Recap, quick overview of previous parts. Part 1 Introduction to API Authentication and Authorization. Why bearer tokens are a good option. Part 2 Defining API key structure, example JWT and storage options, databases, redis. Part 3 Implementing token generation and issuance. User registration / login and API key creation. Part 4 API key validation and authorization. Middleware implementation to verify tokens. Part 5 Error handling and security considerations, XSS, CSRF, rate limiting. Part 6 Token expiration and refresh tokens. Implementing refresh flows for continued access. This tutorial, Part 7, will cover 1 Token rotation, 2 Token revocation, 3 Multi-factor authentication, MFA, integration, 4 Token store optimization, 5 Monitoring and auditing, 6 Security best practices, advanced, 7 Code examples, illustrative, 8 Conclusion. 1 Token rotation. Concept Token rotation involves automatically issuing a new API key / access token and invalidating the old one after a certain period or after a specific number of uses. This significantly reduces the window of opportunity for attackers to exploit a compromised token. Even if a token is intercepted, its usefulness is limited. Why token rotation is important compromised token mitigation limits the damage from leaked or stolen tokens. Enhanced security posture adds an extra layer of defense against unauthorized access. Compliance requirements some compliance standards mandate token rotation. Implementation strategies periodic rotation new tokens are issued on a scheduled basis, example every 24 hours, weekly. This is suitable for general API usage. Use-based rotation tokens are rotated after a specific number of API calls. This is useful for high security applications. Event-triggered rotation rotation is initiated by specific events, such as detected suspicious activity or changes in user roles. Considerations grace period implement a grace period where both the old and new tokens are valid concurrently. This avoids breaking existing integrations during the rotation process. The grace period should be short, example a few minutes to an hour. Database updates ensure atomic updates to the token store when rotating tokens. This avoids race conditions. Client-side handling the client application needs to be designed to handle token rotation seamlessly. It should automatically request a new token when the current one expires or is invalidated. Code example, illustrative, Python with Flask and a simplified token store. Explanation 1 Generate _token, generates a JWT with a unique JWT ID, to track the token. 2. Verify underscore token, asterisk verifies the JWT, checks if it's expired, revoked, or invalid, and checks if the token is actually in the store. 3. Rotate underscore token, asterisk generates a new token and then revokes the old token. Revoking the old token first can lead to downtime during the update. 4. Revoke underscore token, asterisk marks a token as revoked in the token underscore store. Doesn't actually delete it, more on that later. 5. Token underscore required, asterisk this middleware now checks for the rotation period before the actual API call. If the rotation period has passed, it attempts to rotate the token and return 401 with a message about token rotation along with the new token. This simulates the client receiving a 401 and then getting a new token. In a real implementation, this rotation should be handled asynchronously via a background task so that API calls do not hang. Important notes about the example asterisk. Asterisk this is a simplified example and not production ready. Asterisk the in-memory token underscore store should be replaced with a proper database, PostgreSQL, MySQL, etc., or a caching system like redis for performance and persistence. Asterisk token rotation checks, in token underscore required, should ideally be offloaded to a background task or a separate service to avoid performance impact on API requests. Consider using Celery or similar task queues. Asterisk error handling and logging are crucial in a real implementation. Asterisk the client-side logic for handling token rotation is not implemented in this example and would need to be added to the client application. It must catch the 401 and use the new underscore token. Asterisk this example uses a simple revocation flag. In a real application, you might want to store revocation reasons. 2. Token revocation. Concept asterisk token revocation allows you to immediately invalidate a token before its natural expiration. This is essential when asterisk a user logs out. Asterisk suspicious activity is detected. Asterisk a token is believed to be compromised. Asterisk user roles or permissions change. Implementation asterisk. Asterisk revocation list, blacklist maintain a list of revoked token IDs, JTIs. This list is checked during token validation. Asterisk database flag asterisk add a revoked flag to the token record in the database. Set this flag when the token is revoked. Asterisk distributed revocation, using redis or similar for high-performance APIs, consider using a distributed cache, like redis, to store revoked token IDs. This allows for fast revocation checks without hitting the database on every request. Code example, building on the previous example. The previous code example already has the core of a revocation system. The revoke underscore token function sets the revoked flag in the token underscore store. The verify underscore token function checks that flag. Adding a revocation endpoint asterisk. Important considerations asterisk. Asterisk database / cache updates asterisk ensure that revocation operations are atomic to prevent race conditions. Asterisk propagation delay asterisk if using a distributed cache for revocation, there might be a short delay before the revocation is effective across all API servers. This is called eventual consistency. Consider the trade-offs between performance and immediate revocation. Asterisk revocation reasons asterisk storing revocation reasons, example user logout, compromised token, can be helpful for auditing and analysis. Asterisk garbage collection asterisk periodically clean up the token store. Remove expired and revoked tokens after a certain period to prevent it from growing indefinitely. A background task is ideal for this. 3. Multi-factor authentication, MFA, integration. Concept *MFA adds an extra layer of security by requiring users to provide 2 or more authentication factors, example password plus OTP from an authenticator app. Integration with bearer tokens *MFA during token issuance require MFA during the login process before issuing a bearer token. The token then represents a successfully MFA authenticated session. Token bound MFA the token can be bound to a specific MFA device or session. This means the token can only be used from that device or session. This is more complex to implement. Step-up authentication for sensitive API endpoints, require MFA even if the user has a valid token. This is called step-up authentication. The API can check if the user has recently authenticated with MFA and, if not, redirect them to an MFA challenge. Implementation strategies 1. Login with MFA user enters username/password. If credentials are correct, trigger MFA challenge, example send an OTP. User enters OTP. If OTP is correct, issue a bearer token. 2. MFA during token refresh The refresh token endpoint can require the user to re-authenticate using MFA. Code example, illustrative, Python with Flask and PyAdP. Explanation 1. User's dictionary stores user credentials and the OTP secret, replace with a real database. 2/MFA/generate root generates an OTP secret for the user, if one doesn't exist, and returns a provisioning URI. The client uses this URI to generate a QR code that the user scans into their authenticator app, example Google Authenticator, Authy. 3/login root collects username, password, and OTP from the user. Authenticates the user. Verifies the OTP using the PyAdP library. If all credentials are valid, generates and returns a bearer token. Important notes security never store passwords in plain text. Use a strong hashing algorithm, example BCRYPT, Argon 2, with salting. Store the hashed password in the database. OTP secret storage store the OTP secret, OTP_secret, securely in the database, encrypted if necessary. User experience provide clear instructions to the user on how to set up MFA and use their authenticator app. Error handling handle errors gracefully and provide informative error messages to the user. Fallback mechanisms consider providing fallback mechanisms for users who lose access to their MFA devices, example recovery codes. Step-up authentication example, simplified you could modify the @token_required middleware to check for an MFA flag in the JWT payload. If the endpoint requires MFA and the flag is not present, redirect the user to an MFA challenge. The subsequent token issued after the challenge would include the MFA flag. 4. Token store optimization. Concept optimizing the token store, database or cache, is crucial for performance and scalability. Strategies indexing add indexes to the token store table / collection on frequently queried fields, example JD, user_ID, expiration. Caching use a caching layer, example redis, MEMC8, to store frequently accessed tokens. This reduces the load on the database. Data partitioning / sharding if you have a large number of tokens, consider partitioning or sharding the token store across multiple servers. Garbage collection, Token cleanup: periodically remove expired and revoked tokens from the token store. Implement a background task for this purpose. Consider also archiving very old tokens to another location if audit trails are required. Connection pooling. Use connection pooling to reduce the overhead of establishing database connections. Code example: illustrative, Python with SQL Alchemy and a background task, requires Celery. SQL Alchemy model, token table. Celery task, for token cleanup. Explanation: 1. SQL Alchemy token model defines the database table for storing tokens. Crucially, it includes indexes on JD and user_ID to speed up lookups. The expiration column is also used for cleanup. 2. Celery task cleanup_expired_tokens, *. Connects to the database using SQL Alchemy. * deletes expired tokens, where expiration is in the past. * deletes revoked tokens that are older than a certain period, example 7 days. This prevents the revoked token list from growing indefinitely. Keeping revoked tokens for some time may be necessary for auditing. Commits the changes to the database. Handles errors and rolls back the transaction if necessary. Closes the database connection. 3. Celery beat schedule schedules the cleanup_expired_tokens task to run periodically, example every 24 hours. 4. Celery app setup shows how to set up Celery, install it and other dependencies, SQL Alchemy, etc. Important notes: Celery configuration ensure that Celery is properly configured to connect to redis, or your chosen broker and backend. Database URL replace PostgreSQL //user password at host port /database with your actual database connection string. Indexing choose the appropriate indexes based on your query patterns. Over-indexing can negatively impact write performance. Chunking if you have a very large number of tokens, consider deleting them in chunks to avoid locking the database table for extended periods. You can use Alchemy's limit and offset methods to paginate the deletion process. Background task scheduling use a reliable task scheduler like Celery Beat or a dedicated job scheduler, example cron, to run the token cleanup task regularly. Monitoring monitor the performance of the token cleanup task and the token store to identify potential bottlenecks. 5. Monitoring and auditing. Concept monitoring and auditing are essential for detecting and responding to security threats. Monitoring API usage track the number of API requests, response times, error rates, and resource consumption. Token usage monitor the number of active tokens, token expiration rates, and token revocation rates. Authentication attempts track the number of successful and failed authentication attempts. Detect brute force attacks. Suspicious activity monitor for unusual patterns of API usage that might indicate a compromised token or a malicious attack. This could include sudden spikes in API requests from a single token. API requests from unusual geographic locations. API requests using unexpected user agents. System health monitor the health of your API servers, databases, and caching systems. Auditing token issuance log all token issuance events, including the user ID, issuance time, and token expiration time. Token revocation log all token revocation events, including the user ID, token ID, revocation time, and revocation reason. Asterisk authentication attempts asterisk log all authentication attempts, including the username, IP address, and outcome, success or failure. Asterisk API access asterisk log API access events, including the user ID, API endpoint, timestamp, and response code. Asterisk administrative actions asterisk log all administrative actions, such as user creation, role changes, and token management operations. Implementation asterisk. Asterisk logging asterisk use a logging library, example Python's logging module, log4j, to record events. Asterisk metrics asterisk collect metrics using a metrics library, example Prometheus, Graphite, and visualize them using a dashboard, example Grafana. Asterisk centralized logging asterisk send logs to a centralized logging system, example Elasticsearch, Splunk, Graylog, for analysis and alerting. Asterisk alerting asterisk set up alerts to notify you of suspicious activity or system health issues. Code example, illustrative, Python with Flask and logging. Explanation asterisk. One logging configuration asterisk configures the logging module to write log messages to the console. You can configure it to write to a file or a centralized logging system. 2 log messages asterisk the code includes log messages for asterisk successful and failed authentication attempts. Asterisk access to the protected resource. Asterisk token revocation events. 3 information included asterisk the log messages include the user ID, IP address, and other relevant information. Important notes asterisk. Asterisk log levels asterisk use appropriate log levels, example info, warning, error, to categorize log messages. Asterisk log format asterisk use a consistent log format to make it easier to parse and analyze logs. Asterisk sensitive data asterisk be careful not to log sensitive data, such as passwords or API keys. Mask or redact such data before logging it. Asterisk retention policy asterisk establish a retention policy for log data to comply with regulatory requirements and manage storage costs. Asterisk security information and event management. SIEM consider using a SIEM system to collect, analyze, and correlate security events from various sources. 6 security best practices, advanced. Asterisk defense in-depth asterisk implement multiple layers of security controls to protect against a variety of threats. Don't rely on a single security measure. Asterisk least privilege asterisk grant users only the minimum necessary permissions to access API resources. Asterisk input validation asterisk thoroughly validate all input data to prevent injection attacks, SQL injection, command injection, etc. Asterisk output encoding asterisk encode output data to prevent cross-site scripting, XSS, attacks. Asterisk rate limiting asterisk implement rate limiting to prevent denial of service, DOS, attacks and abuse of API resources. Implement different limits for different users /API keys /endpoints. Asterisk API gateway asterisk use an API gateway to centralize security controls, such as authentication, authorization, rate limiting, and traffic management. Asterisk regular security audits asterisk conduct regular security audits to identify vulnerabilities and weaknesses in your API. Consider penetration testing. Asterisk security awareness training asterisk train developers and operations staff on security best practices. Asterisk keep software up to date asterisk regularly update your software and libraries to patch security vulnerabilities. Asterisk transport layer security, TLS use TLS, HTTPS, to encrypt all communication between clients and the API server. Ensure that TLS is properly configured and that you are using strong ciphers. Asterisk content security policy, CSP implement CSP to prevent XSS attacks. Sub-resource integrity, SRI use SRI to ensure that third-party JavaScript libraries have not been tampered with. Regular expression denial of service, redis be wary of complex regular expressions that can cause redis attacks. Secrets management do not store API secrets such as token keys, database passwords, or API keys in the code base. Instead, use a secrets management service such as HashiCorp Vault or a cloud-native key vault provided by your cloud provider. 7 Code examples, illustrative. Throughout this tutorial, we provided code examples to illustrate various concepts. Remember that these are simplified examples and should not be used directly in production without careful review and adaptation. Key areas where code examples are helpful. Token generation generating JWTs with appropriate claims, user ID, expiration, JTI. Token validation verifying JWT signatures, checking expiration, and looking up tokens in the token store. Middleware implementing middleware to protect API endpoints. Token rotation generating new tokens and revoking old ones. Token revocation marking tokens as revoked in the token store. MFA integration implementing MFA challenges and verifying OTPs. Token cleanup deleting expired and revoked tokens from the token store. Logging recording security events. Example code is provided throughout this tutorial to exemplify these sections. 8 Conclusion. Bearer token API key authentication, when implemented correctly, is a robust and secure method for protecting your APIs. This tutorial series has covered the essential aspects of bearer token authentication, from basic principles to advanced topics such as token rotation, revocation, MFA integration, token store optimization, monitoring, and security best practices. Key takeaways Security is paramount. Always prioritize security when designing and implementing API authentication. Defense in-depth. Implement multiple layers of security controls. Regularly review and update your security measures. Security threats are constantly evolving. Monitor and audit your APIs. Detect and respond to security incidents promptly. Choose the right tools and technologies. Select tools and technologies that are appropriate for your specific needs and security requirements. Follow best practices. Adhere to industry best practices for API security. By following the principles and best practices outlined in this tutorial, you can build a secure and reliable API authentication system that protects your valuable resources. Remember to stay informed about the latest security threats and to continuously improve your security posture. Good luck building secure and robust APIs.